Hi Geometry. Let's work with our volume formula for pyramids. This is Unit 5, Lesson 14, page 613 in your workbooks. On this page we have two pyramids. So the first pyramid is a rectangular pyramid because my base is a rectangle. And the second one is B. This is a triangular pyramid. And A is a rectangular prism. So what you need to be careful about when you start having both types of shapes on the same assignment is that you remember to keep your volume formulas straight. So first of all, let's do the rectangular prism since we've been doing this for a while. Its formula is big B times H, where big B is your base area. That would be the length and width of my triangular base times then the height of my entire prism. Because my prism is made up of a stack of rectangles 2 units tall. The area of that rectangle is 5 times 4 times the height of 2. So the volume of this then is 20 times 2 or 40 units cubed. So let's take a look at the rectangular pyramid right above. This formula for volume is actually 1/3 big B times H because this is not a stack of congruent rectangles for 6 units tall. This is a stack of rectangles that is getting smaller as I go up to the top of my pyramid and I finally get to a point. My rectangles are shrinking as I go up. So my volume is getting smaller than if it had been a prism. It's 1/3 as small, so let's calculate that. So this is 1/3 times the area of the base. The area of my base is length times width, since it's a rectangle, times the height of my entire prism. So my big B is length times width. So this would be 1/3, 5 times 4 times 6. This is all multiplication. You can do it in any order you want. I might do the 5 times 4 times 6 because in my head I know that's 20 times 6. And 20 times 6 is 120. 1/3 times 120 is 40. So I also know that this is 40 units cubed. So these two happen to have the exact same volume. So let's take a look at the triangular pyramid. The triangular pyramid's volume is 1/3 big B, the area of the base, times the height. So in a triangle, the area of the base is 1/2 the triangle's base times the triangle's height, and then again times my entire volume. So this big B is what I have in red. Sometimes it gets confusing for students to see a couple fractions and a couple H's, so you do need to keep them straight. So let's fill in for my prism first. It's 1/3 times my height of my prism, which is 10. And now let's fill in the information for my triangular base. So my triangle's base and height have to be perpendicular to each other, so that is the 4 and the 6. It's not the hypotenuse over here that's dashed and blank. I don't need that. So then this would be 1/2 times 4 times 6. This is multiplication of 5 things. 1/3 times 1/2 times 4 times 6 times 10. You could just put each number into your calculator times equals, and you're done. If you're going to organize them, I might do what's in parentheses first. So for me, I would be looking at doing volume equals 1/3, and inside the red parentheses, 4 times 6 is 24, half of that is 12, times then the 10. And so I might look at this as 120 times 1/3, because 12 times 10 is 120, and I would also get 40. That's without using my calculator, just kind of breaking it down and doing the parts in my head. But you can work that out in different ways. It's multiplication. Multiplication is commutative. You can multiply those 5 numbers in any way you want, but note there's no distribution property here. That's not what's going on. It's all multiplication. So on this first page, all 3 of these items have a volume of 40 units cubed. So this page contains 4 pyramids or cone that uses our new formula, volume equals 1/3 the area of the base times the height. So why don't you pause this video, take some time and try A, B, C, and D. Keep a note when you do D, they actually tell you the area of this entire base. They give you big B in the problem. It's actually the easiest of the 4 problems in that sense. Calculate then the volumes and then play this video to check your answers. If you miss a couple of them, pause the video, make corrections to your work, and bring your questions to either our Zoom class, our in-person class, or office hours that you have on A, B, and C. So at this time, pause the video and try those, please. Welcome back. So my 4 answers to these problems are listed above. Notice I had to write C out to the side. So for A, you should have got 8 feet cubed for that square pyramid. For B, you could write the volume of the cone as 5.6 pi centimeters cubed or 17.6 centimeters square or cubed. Sorry, that was my problem there. Cubed. If you want to multiply by pi. For C, it's out to the side. It's 14 kilometers cubed. And then finally for D, it's 128 centimeters cubed. So let's take a look at number 2. A particular cone, just like in B up above, has a particular radius and height. Write an expression for the volume. So we know that to be 1/3 big B times h, which if it's a cone, my base is a circle. So it's pi r squared times the height. Pi r squared for the base, which is a circle. Now this question is different than the top 4. I am not looking for my volume. It says, what is the height? Oh, I'm going to be solving for h. The volume is 16 pi cubic units, and the radius is 3. So let's put that information into my formula. So 1/3 pi times 3 squared times the height. And actually, let me erase my v. I didn't want to write v in this problem because I know my volume. It tells me my volume is 16 pi. So I want to solve for h here. Again, you can do your algebra in different ways. Completely up to you. For me, when I look at this, the first thing I notice is that it's all multiplication on both sides. And I have a pi on both sides. So the first thing I would do is divide both sides by pi. When I divide both sides by pi, it cancels. On my left side, I have 16 equals 1/3 times 3 squared, which is 9, times h. 1/3 times 9 is 3. So I've got 16 equals 3h. Divide both sides by 3. I get 16 over 3 equals the height. You can leave your answer like that, or on your calculator, 16 divided by 3 gives me 5.3 repeating. And this would be, I guess in this problem, just units. It doesn't tell me what my measurement units are. So then it goes on, this next question, see, we need to find the radius. So this is asking for the radius. My volume is the 16 pi, and now my height is the 3. Okay, so let's fill this in. My volume, V, is the 16 pi, equals 1/3 pi times, I don't know the radius, times 3. So again, just like B, when I first look at this for my algebra, I happen to notice it's all multiplication, no plus signs anywhere. So I can divide both sides by pi. My pi's cancel from both sides. That's great. I also notice on my left side, I have 1/3 times r squared times a 3. If I multiply the 1/3 times the 3, they cancel. And I would get then, on my next line down, 16 equals r squared. So now I can take the square root of both sides, and I get 4 equals r. So my radius is 4. These are units. Okay. So 14.3 on page 615 is the idea of knowing information about my pyramid and having to solve for a particular part that's missing. So let's take a look at this problem. A baker's making a pyramid out of chocolate, okay, for a special display in a store. Has 20 pounds of chocolate. So, and it says, which is about 720 cubic inches. Cubic inches. This is the volume then of my chocolate figurine. It's going to have 720 cubic inches of chocolate, which is about 20 pounds of chocolate, which sounds delightful. The pyramid must be 15 inches tall, so that would be the height. So they need to decide how large to make the base, which can be any shape. Draw and label the dimensions of two different bases. So first of all, before I can even think about my base's dimensions, whether it's a square or rectangle or triangle or circle or pentagon or hexagon, I have to figure out what is my base area. So let's look at the formula for the volume of a pyramid. It is 1/3 big B times H. And so in this problem, my volume is 720. My big B is what I don't know. And my height is 15. So I notice on my right side, I have 1/3 times big B times 15. If I multiply 1/3 times 15, my 15, which is over 1, cancels to a 5. And so really, this is 720 equals 5 times big B. Let's divide both sides by 5. And then I get that my big B is equal to 144 units squared. So in this case, I really just need to think of two shapes to be my base that has a volume, or I'm sorry, an area of 144. So any shape works, anything. So you could say I'll have a square base, okay, that has sides 12 and 12. Great, that works. You could say I'll have a rectangular base, and you have a bunch of numbers you could put here. I believe 144 is divisible by 8. Let me check. Divided by 8, it is. So I could have 8 and 18 for a rectangular base. You could even think about doing a pyramid with a triangular base, but be careful. I don't want my triangle's base to be 144. Remember, the area of a triangle is 1/2 base times height. So if I want that to be 144, I'm really looking at two numbers that when I multiply them is actually 288. So I'm really trying to look for that. So 288, let's see, is that divisible by 12? It's not by 10 for sure. So we could say 12 and 24. That would give me a base area, again, of 144. So this has, your answers can vary widely for this problem. Any shape is good for your base as long as it has an area of 144 units squared. This pyramid will have a height of 15 and its volume will be 720 cubic inches. Thank you.